Now that we have loaded all the data and processed all the data, we might want to save that data for posterior use within the workflow, or just export to load somewhere else. So first of all, before we can export the data, we usually define some folder. So alt-dir is going to be my folder, and I'm going to call it output. And in order to create that folder, I'm going to use rmsp.makedir function. So if I run this cell, it's going to create an output. You can see that a folder has been created. And the first type of export that I'm going to be demonstrating is the CSV. So in order to create a CSV, we can actually use a function that's coming from the pandas data frame. So our comps, as I mentioned, is a pandas data frame. It is a geo data frame, and it is a interval data. So we can use the functions from the pandas data frame. So pandas data frame has this function that's called toCSV, and this function requires us to specify the path for the file. So that's gonna be my output folder plus the name I want to give for this file. So I'm gonna call it composite.csv. Another common argument here that we might want to use is the index equals false. This is a very common one because not always we want to be exporting to the CSV these indexes here. If they don't have any meaning, that's just wasting space on your hard disk. So in this case, we do not want the index, so I'm gonna say index equals false. So if I look at my output folder, I now have my composite.csv, and I can see that I'll have all the information in here. One thing that you might notice is that I have missing information for the density, and that's just blank records. There's nothing filling the data in here. You might want to specify the missing data. It might be important for some softwares. So for that, what we can do is use another pandas function. So first, let's take a look at the data. So we have some missing data, and we want to kind of replace all that missing data by some other number. So what I can use is something called fill NA. So this is gonna fill all the missing data with whatever I specify in here. So let's say we want to use -999. So if I do that, of course, I need to capture the output. So now all my missing data is replaced by -999. So what I can do is to add this in here, and this will convert the columns, fill the missing, and write the CSV file. So if I do enter, my CSV has the -999. If I want to read this file now, what I can do is to do df equals bd, read CSV, and use the same name in here, and do a type df. And if we read, we will see that this is a pandas data frame, and that's being loaded from that CSV. And we can take a look at the content. We should see the missing values that we specified. The CSV format is a nice format to save your data because you can load it pretty much everywhere. But as you may notice here, when I do this type df, and I'm just gonna do display, this is a pandas data frame. So when you save the data as a CSV, you want to load it later on, you will have to convert it back to some useful RMSP object. You won't know what the object is just by loading it from a CSV. So alternatively, other types of export that you might want to use is, for instance, pickles. So pickles are a form of data file that you can use that's okay for short-term storage. And the reason I say that is because say that you save a pickle of a data frame today and you want to just load into the next step in your workflow. So you're just using that pickle at the same time you're generating it, basically. But if in a few months from now you want to load that pickle and you have updated your environment, you have a different pandas version on your computer, you might not be able to load that pickle anymore. So that's really only meant for short-term storage, where I'm generating this output on this notebook and then I'm gonna almost immediately be using that output on the next step of my workflow, and I'm not gonna be caring about that data anymore in the long term. So in order to use pickles, you can do rmsp.toPickle, and then you can save the composites with the output folder and say composite.pickle. So this will save the composites, and it's out there. This will save the composites into this output. If I try to load it, it doesn't make any sense. It's just a binary format. So that's one of the reasons it's not like future proof and you cannot load it in any software. You can only load it in Python using a pickle loader. So we saved that pickle file, and let's say now I want to use it. So let's say I can do df equals rmsp.fromPickle. So that's the function to read the pickle back. And we can specify the name of the file, and this should give me the pickle back. So if I read a pickle file, the advantage of it is that now it knows it is an interval data and I can use it right away. We can just go df.view3d and all the information of that pickle is already stored. With the CSV here, we wouldn't be able to do that. We cannot do a view 3D on just a pandas data frame. So that's the advantage of using the pickle format, is that as soon as we load it, it already has the correct data type that we want to use. Alternatively to Pickle, there's another format that we can store the data and still be able to load it with some useful data type, which is the JSON format that RMSP implements. So this is more for a long-term storage compared to the Pickle, because we can make sure that in the future you're going to still be able to load this data within RMSP. So in order to save a JSON, you can do rmsp.saveJSON and pass your composites, and now just specify the name. I'm gonna copy it from here and just change the extension. So this is gonna save the JSON file. If I want to load it, I can do df.rmsp read JSON, and I can pass the file name to this function. And we can again just check the type and the head of the data. So if I run this, it will save that into a JSON file. So if I go to my output, it now has these two files. So you will see that sometimes when we save a JSON from RMSP, it's gonna save this JSON file which contains some information, and it will also save additional files. In this case, it's just one, which is a Parquet file, which contains some of the data that goes into this data frame. So it does generate more files. but you are able to load it and still have a interval data built out of the file you're reading. So it remains with the useful format and is more future-proof, and it's more adequate for long-term storage compared to the Pickles. Both of these last two exporting formats, the Pickle and the RMSP.save JSON, will require you to have RMSP in order to load the data you just saved. A last alternative in order to save data, we know that CSVs can take a lot of space. It's not optimized at all. So another alternative format that we can save the data is coming from the pandas data frame as well. So we can just do comps.toHDF format, and I'm gonna just give a file name, which is gonna be composite.hdf. And for this particular save, we need to specify one extra argument, which is called table. And I just use, key, and I just call the key table because we are saving a data table inside this HDF file. So if I run this cell, it's going to create this HDL file. And if I go to the output, this HDF file, we cannot read it because it's a binary file. But if you look at the size of this file, is compressed and optimized, so it's much smaller than a CSV. So this makes for a good format for long-term term storage, where you want to save it in compressed format. In order to read this type of file, you can do df equals to pd read hdf and add the name of the file, and you need to specify again the key where you saved the data, and this will load the data frame. I will copy those last two lines of code here just to demonstrate. So when we save with the HDL format and load it back, you get a pandas data frame. So you're not getting a interval data anymore because it doesn't know about all the metadata that you have specified. So the main advantage here is to have that compressed data format for long-term storage. The only drawback from it compared to CSV is that CSV you can load in many other softwares, and HDF will require you to have pandas in order to load it back. Some other software and Python packages might be compatible with it, but it's more restricted than CSV file formats.